In this video, we will discuss the role of belief and introduce Nash Equilibrium, which is one of the most important concepts in game theory. So this is another famous game, so-called the stag hunt game. Perhaps this situation was introduced in 18th century, around 200 years before the prisoner's dilemma was introduced. So some people consider Rousseau as the first game theorist in some sense. So this situation can be simplified in this payoff matrix. So if both players keep their post for stag, then the outcome is good. So each player gets 10. But if your opponent chooses hare, where you still keep post for stag, then you will get nothing. On the other hand, if you choose hare, then you will get hare for sure. So it guarantees a payoff 2. So please recall that in the previous video, we discussed that assuming common knowledge of a game and common knowledge of rationality, players iteratively eliminate their dominated strategy. So such an elimination process may yield some plausible outcomes. However, in this game, rationality or common knowledge of rationality does not help. So we cannot even initiate any elimination. Of course, if you know your opponent's action, then you can choose your action accordingly, but such communication may not be possible in such situations. In such a situation, belief matters. If I believe you will play stag, then I will choose stag. If I believe you will play hare, then I will play hare. In fact, belief is based on trust, as Rousseau understood. When I believe you will play stag, I should also believe that you believe that I will play stag. If I'm not sure whether you will play stag, then I would be reluctant to play stag. If I wanted to play stag, but you may not believe that I'm going to play stag, then I would be also reluctant to play stag, unless I can convince you to believe I will play stag. So what you have to do depends on what you believe about your opponent's action. If you believe your opponent will play stag, then stag is better. So your best response against your opponent's stag is stag. Similarly, your best response against your opponent's hare is hare. So now we can define the Nash equilibrium as the mutual best responses. In the payoff matrix, players' best responses are marked with underline. So player 1's best response against player 2's stag is stag, not hare. And against player 2's hare, player 1's best response is hare, not stag, right? So we underline those strategy, those actions as player 1's best response, and similarly, player 2's best response is marked with underline. So stag is player 2's best response against player 1's stag, comparing 10 and 2. So 10, this stack is best response. And comparing 0 and 2, this hair is player 2's best response against player 1's hair. So we have two outcomes that involves with both players' best responses, stag and hair. So we have two Nash equilibria, both play stag and both play hair. So just one remark, the word equilibrium is Latin origin, so this is a plural form is equilibria. So this is the first quiz of this video, and it is to find a Nash equilibrium in this prisoner's dilemma situation. And importantly, if each player has a dominant strategy, then the dominant strategy forms an equilibrium. And the second quiz, so prisoners find an equilibrium, and there is a relationship between the Nash equilibrium and iterative elimination process. And equilibrium consists of the strategies which survive from iterative elimination of a dominating strategy. So please post your answer to our team's channel.